Chapter 5, Lesson 1. This lesson focuses in on lines. Let's first focus in on some definitions and some vocabulary. The very first definition we want to look over at that picture on the left. I see two intersecting lines, and that box we see right there at the angle represents this is a 90-degree angle or a right angle. That means it represents perpendicular lines and the definition for that are two lines that intersect in a plane and form right angles. We also have a bit of notation whenever we talk about two lines being perpendicular. We can use a symbol. This symbol is an upside down T. For example, in this picture, we could say that line AB is perpendicular to line CD. Next, I see two lines, but they seem like they are never going to touch each other. Well, when two lines are on the same plane, and do not intersect, we call them parallel lines. We also have some notation for that, where we could see it in a couple different ways. Your textbook uses the following. We could say of these two lines, maybe I call this line L and line M. We could say line L is perpendicular to line M at the poor looking end. But just wanted to give you a quick look at what the notation might look like. Now, as we move forward, we have a few more pictures here. And in this first picture, we have two parallel lines with one line that intersects both of them. Well, in this case, we're talking about line T, and when we have the following, a line that intersects two or more lines, we call that a transversal. And it's really going to be the main focus of what we're talking about. The big thing here is we're going to talk about some special properties that are formed when we have two parallel lines that have a transversal cutting through it. So let's start off with some definitions of those special relationships to make it clear. We have about 4 things to talk about. First, look at these numbers, 3, 4, 5, and 6. 3, 4, 5, and 6. Those represent for us some special angles. And first, I want to talk about where are they located. These are inside of our picture. They are in between the two parallel lines. We're going to call those interior angles. Because they lie inside, in the interior of the lines. So interior because they're inside, they're in between everything. Next, if we talk about 1, 2, 8, and 7, they're not inside anymore. They're actually on the outside or the outer edges of our picture. We could call those exterior angles. Sorry, forgot how to spell for a second. That's because they lie outside the lines. Next, we're going to talk about some special relationships. In these next 3, we're going to talk about how some of the angles may or may not be equal to each other. To start, I want to focus in on this picture. Do you notice where it says C1, C2, D1, and D2? We're talking about interior angles, and I want you to think about this one piece, D1 and D2. Are they on the same side, or are they on opposite sides of the transversal? Remember, the transversal is this line here. Since those green dots for D1 and D2 are on different sides, or what we could call alternate sides, these are alternate interior angles. So they are interior angles on opposite sides of the transversal. And they have a special property. The reason why they are marked as D1, D2, C1, and C2 is because we can make the statement that the measure, or M, of angle, so we use that wedge shape for angle, C1 equals the measure of angle C2. Also, the measure of angle D1 equals the measure of angle D2. So we're focusing on angles that are equal to each other. Our next image we have A1, A2, B1, B2. We have our transversal. These are our exterior angles this time. And I want you to notice, similar to the example above it, A1 and A2 are on opposite or alternate sides of the transversal. So these are alternate exterior angles. Similar to the definition above, they are exterior angles on opposite sides of the transversal. And very similar to the example above, I'm just going to give one. We could say that the measure of angle A1, and not the steak sauce, equals the measure of angle A2. Sorry, geometry has a lot of humorous things. I'll try to keep it to a minimum. Now, one more thing I want to talk about is these are going to be angle pairs that are not quite both interior or both exterior, and they're not going to be on opposite sides. I want to talk to you about what they're called. If you look at these angles I just marked, what does it appear that we could say about those angles? They almost look the same. They may very well be the exact same position. And that's what we're going to talk about. These are called corresponding angles. And with corresponding angles, we could say that they are angles that lie in the same position on two lines in relation to the transversal. Now, it's a lot of words just to say we have two angles and if we look at those two shapes, here and here, it shows that along that transversal, J1 and J2 are in the exact same position on their respective lines. And because of that, we can say that the measure of angle J1 is equal to the measure of J2. So next, I want to flip over to a notes page for us to put these to use. It's a lot of definitions, some of which, such as these first two, you've seen before, but we're adding in the transversal and talking about what does that mean for all the angles inside. Pause this video at any point that you need and go back and make sure you have these definitions. Geometry is heavy on definitions, and it's going to be important to know how to label and discuss each of these pieces. All right. Now the definitions, the big ones, are at the top of the notes page. This is the reteach page you normally find on the back of your homework. Let's take a look at the examples for a second. Example 1 just says to classify angle 4 and angle 8 as either, so we've got choices, alternate, sorry about that, alternate interior, alternate exterior, or corresponding. Well, if I look, here's angle 4, here's angle 8. If you were to look at the pictures on the other page, we would see that these are two angles along the transversal that lie in the same position on the two lines. Thus, they are corresponding angles, and you just want to make a statement as the following. Angle 4 and angle 8 are the same position in relation to the transversal on the two lines. They are corresponding angles. All it is you're stating the definition. And you could be asked to do that for any of those three relationships. Next, example 2 could say, look up at example 1. So the picture we already marked on. Since angle 2 and angle 8 are alternate and, let's back up, I'm sorry. Not even reading that yet. The question asks, find the measure of angle 2 if the measure of angle 8 is 58 degrees. Well, we're talking about 8 and 2. This angle is 58 degrees. And we want to know, can we use that to make some sort of assumption about angle 2? I just wrote X because we don't know what it is yet. We look at their angle pair relationships. And if I had some more forethought, I would mark this in green because I used that for alternate exterior before. Since angle 2 and angle 8 are alternate exterior, we can say that the measure of angle 2 equals the measure of angle 8. And since the measure of angle 2 equals 58, all I'm going to do is substitute. Instead of the measure of angle 8, I'm going to plug in what I know about angle 8. And that is, that should say angle 2. That the measure of angle 2 equals 58 degrees. And below, we're going to put all of that together. We're going to talk about why certain angles are equal or how we can use it to determine what is and what is not equal. And we're also going to have to justify our answer, meaning we're going to have to identify what type of angles they are, what the measure is, and to justify, well, why is that? If you noticed above how I was drawing on the picture to give you guys some reference, I highly suggest, since we are in a geometry unit and geometry is a very visual subject, I'd suggest writing on the pictures as much as possible. So let's take a look. In this exercise, if measure of angle 3 is 64, we want to figure out what's the measure of angle 8. So I go to my picture, and honestly, I'm going to write that in. I'm going to say this is 64 degrees. And I'm going to mark this 3 and 8. I mark it like that so I can refer back to the notes for the definitions. And I see the following. Angle 3 and angle 8 are corresponding so the measure of angle 3 equals the measure of angle 8. Since the measure of angle 3 is 64, measure of angle 8 also equals 64 degrees. It is very important to be able to verbalize that, so you are going to be asked to write this as part of your answer. All right. I do find it helpful, either use color pencil or write lightly on your picture so you can erase just something, because these pictures can get cluttered very fast, but again, I find it so helpful to mark everything that I know, such as I still know that this is 64. But we want to find, we know this angle, we want to find angle 10. Now I want you to see something. Are these interior or exterior? Are they on the same or opposite sides of the transversal? In this case, our transversal is P. Well, angle 3 and angle 10 are alternate interior angles. That means for us that the measure of angle 10 is equal to the measure of angle 3. So the measure of angle 10 is 64 degrees. As we continue with the next two examples, there's two more definitions I need to make sure you know. We're going to talk about what's called a supplementary pair of angles and what are vertical angles. Let's use number 3 as an example. In number 3, we're going to have to skip around a little bit. And that is by the following. A supplementary angle is an angle, or supplementary angles are any angles that form 180 degrees or a straight line. I know this is 64. I know one other thing in the picture. Angle 5. Angle 5 is 90 degrees. That can help me figure something out about the measure of angle 4, our unknown. If you look, all three of these angles together end up forming the straight line for M. This means that angle 3 is supplementary to angle 4 and angle 5 when we put those together. This gives us a new relationship. A straight line will equal 180 degrees. So the measure of angle 3 added to the measure of angle 4 and the measure of angle 5 will have to equal 180 degrees. We can do some substitution. We know measure of angle 3 is 64 plus the measure of angle 4 plus angle 5 is 90 degrees equals 180. We can add these two pieces together to give me that the measure of angle 4 plus, let's see, we should easily find that 64 plus 90 is 154. That equals 180. If I wanted to solve for just the measure of angle 4, our chapter 2 skills tell us to subtract and subtract to find the measure of angle 4 equals 26 degrees. And that's my answer. So it can have a little extra work sometimes. This is one I want you to pause, go back and listen to. Watch it again because supplementary angles is going to be one that might be a little different for you. We have another one that's called complementary angles, but as I look ahead, we're not going to need those right now. Now for angle 6. Angle 6 is going to use one of our other definitions. A new definition we're going to use is what's called a vertical angle. If we look at angle 6 and angle 3, those represent, so angle 3 and angle 6 are what we call vertical angles. I think of vertical angles as being opposite angles. When we have this, two parallel lines cut by a transversal, vertical angles give us that the measure of angle 6 equals the measure of angle 3. So, measure of angle 6 equals 64 degrees. Pause this, go back, watch any portion of this that you are not clear of so that we can use this to help us through some practice.